Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 42 in our legendary, our epic, our new improved series of Arduino tutorials. What we are going to be learning today is we are going to learn how to use a serial to parallel shift converter or shift register. It is the 74HC595, which is kind of a classic serial to parallel converter or serial to parallel shift register, and we're going to learn how to use that today. This is going to be one of the most intense, in-depth lessons that we've had so far. A lot of things that we hook up, a lot of things that you're going to have to do, a lot of new things to learn. So I will need you to pour yourself a nice, enormous mug of ice cold coffee. You will need it today. I will need you to get out your eLego Super Starter Kit. If you do not have one, look at the description. There's a link that'll take you to Amazon. 35 bucks, you can get the whole kit. And guys, seriously, it is a lot easier if you and I are working with the exact same hardware. So when you do this, when you get the kit, then we're working with the same components, and it makes it a little bit easier to learn. Okay, what is this nonsense of a serial to parallel shift register or a serial to parallel converter? Well, you know, on the Arduino you have digital pins. You have digital pins 2 through 13, which you can do things like control things. You can hook LEDs up to them. You can do all types of cool things, but you will learn as you start doing projects that very quickly you start running out of digital pins. And one of the things is, like, imagine you wanted to make an LED bar graph. Okay, if you were going to make an LED bar graph with let's say 8 LEDs, very quickly you're going to be using up those digital pins. And then the other things that you might want to do, like let's say that you might want to have some sensors and some servos and things connected, you very quickly run out. So the idea between a serial to parallel converter is that you have a chip, and that chip hooks to the Arduino through just a couple of digital pins, and then Arduino pushes the data to it serially. It catches the data, and then it outputs it to an array of LEDs. And so you in effect get free pins when you use one of these shift registers. So for today's project, you are going to need 8 LEDs. I use 4 blue and 4 red. It is a special occasion. You are allowed to use the blue LEDs today because it is a rather difficult, rather involved lesson. You need 8 330 ohm current limiting resistors. And in your kit, you need your 74HC595 serial to parallel shift register. Now notice that there is this serial to parallel shift register in your kit. There is also an identical looking device, which is a motor controller. You have to make sure that you're getting the shift register. You have to look at it very closely, and you have to read on there the letters 74HC595. And when you do that, you know that you have the shift register and not the motor controller. Very, very, very important. Okay, let's kind of start talking about this thing and how it works. Let me bring up like a bond diagram. And so again, this would be looking at the chip in let's see. Let me go to this crazy view. This is probably the craziest view that I've ever tried to give, but this is looking at the chip in this direction. And let's go through and let's talk about what those pins are doing. All right, so the first pin, which up here is labeled Q1. You see we've got Q1, Q2, Q3, Q4, Q5, Q6, Q7, and then up and around the corner at pin 15 we have Q0. So from Q0 to Q7 we have 8 pins. Those are the output pins. Those are the pins that are going to be turned high or low. So there you could connect 8 LEDs, or you could connect 8 of whatever it was that you wanted to control. Okay, so that's getting the data out. You also need to get the data in. And so if you go on the pins 1, 2, 3, 4, 5, 6, 7, 8, around the corner to 9, 10, and 11. Okay, pin 11 is a very important pin, and pin 11 is the shift register clock. And so that is going to be your clock signal that allows you to synchronize the data that you're sending out from the Arduino into the shift register. So that is your clock pin. We also are going to use pin 12, and pin 12 is your latch pin. So this chip has to know when the data is coming. How does it know when the data is coming? Well, you send that latch pin low, and then you send the data, and then you bring the latch pin high. So that latch pin lets the chip know data on the way, listen up. Then the clock pin synchronizes that data so that it comes over smoothly. Now you can imagine there needs to be a pin that the data comes over, and that is going to be pin number 14. Okay, pin number 14 on this chip is the serial data input. So Arduino will connect to pin 14, will spit out data. So let's talk again about how this works. First of all, you take your latch pin, you set it low, and that is pin 12. Then you send the data in on pin 14, and then you bring pin 12 back high. And then pin 11 in there is working to get the coordination so that the timing is right. Don't worry so much about this because there is a simple command in Arduino that will take care of a lot of this. I will tell you that the hardest part about this is going to be to get the whole thing hooked up, because you can imagine Q0 to Q7 we're going to have to hook to LEDs and current limiting resistors. You can see pin 8 above is a ground. We're going to have to hook that up. Pin 16 has to go to a voltage, and then there's a couple of more pins on there we've got to set high or low. And so 90% of the battle on this project is going to be to get this darn thing hooked up. Now this is what we are going to hook up. Okay, 8 LEDs, 8 current limiting resistors, the 74HC595, and then all hooked to the Arduino. You can get this little circuit. I think I'm better off here. You can get this little circuit on toptechboy.com. If you go to lesson number 42, Arduino tutorial 42, you can find this if you want to look at it in more detail. But I'm going to be hooking it up, and you can follow along with me step by step as we make this build. Okay, now we are going to go to one of the most insane shots that I have ever tried to create in my history of producing these things. So you can see above me is the circuit that we're trying to build. You can see over here is a description of the chip and sort of an overview of what goes where. I'm going to have to get further out of your way. There you go. And then here is a live shot of the build. And then here in front, right over there, I've got sort of another live shot. So hopefully with these two live shots and the pinout and me, you are going to be able to follow along. But let me just kind of start by going to the big view, the simpler view, and look at this and see what we're trying to do. Let's build the LED circuits first. So we're going to have 8 LEDs. If you look at this diagram, the LEDs all have a common ground, and so the ground is going to be the short leg of the LEDs. So we just need to stack those LEDs in there, and we need to have the short leg going to that top rail, and then that top rail we're going to make a ground. And so let me go back to our monster shot here. All right, so I'm going to start, and I'm going to start on the left with the blue LEDs, and I'm going to be putting the short legs into that top rail. Okay, so let's see what the easiest way to see this is. Short leg into the top rail, and then like that. Okay, short leg into the top rail. I am going to skip one row. Okay, I'm going to skip I guess I should say I'm going to skip one column, and then short leg into the top rail with a little luck. Okay, this one's a little tough to get in, but I will get it. Okay, short leg into the top row. We now have 2 of our LEDs in. We will skip a column and come as such. All right. And I want to kind of keep them lined up and keep them looking good, right? Now we'll get the 4th one, skip a column, and then the short leg into the top row. Okay, so let's see if you can see that nice and good. All right, I got 4 in. And now we'll come in with the reds and skip a column. Let's see if I can get this a little closer there. Okay, so short leg into the top row. First red one. This is a new breadboard, and sometimes the new breadboards are a little hard to get the pins in the first time they go in. So okay, there we go. I got 5. Now skip a column, come in again, short leg in the top row. Okay. And guys, I don't like to force those things in there because I don't want to bend the pins any more than I have to. Okay. And sometimes if you really try to jam it down in there, you mess the pins up. Okay. Skip a column, short leg in the top row. All right. So there I have 8 LEDs. I am kind of obsessive compulsive, and I like them to line up and make a nice little display. Okay, that looks pretty good. This one is a little low. Let me see if I can bring it in alignment a little better. That one's a little low. Okay, I would say that looks pretty good. So now that is, let me see here, make sure, yeah, that is up top there, the LEDs in. Let's go ahead and establish that common ground at this point. And so what we know is, we know that that whole first row needs to be a ground. And so I'm going to bring that in over here. I'm going to bring that into the G and D, which is right there. And so now that top row is in fact a ground. And I am wishing that I had a little more focus on this thing. Let me see if that helps. Okay, hopefully that focus isn't too bad there as I'm working on this. So now I have the ground established. Now let's go in and let's put in our current limiting resistors. And so the current limiting resistor is going to go from the long leg of the LED, and then it is going to stay in the same column but jump across the trench. And by doing that, I'm not shorting out the current limiting resistor. Okay, so you see that? I'm jumping across the column trench. I will put in the second one now to the second LED. Okay, that looks good. Going for the third one. Man, I am just imagining all the hate that I'm going to get on this. But, you know, it's just build it with me. If you're so smart that you can just do it looking at the schematic, go do it. But there's a lot of people that like to kind of be stepped through things. And so don't hate me if I'm kind of trying to step through this for the people that need a little more help. Okay, current limiting resistor number 4. Do you see how I'm trying to keep my circuit really neat? Everything kind of lined up, everything sort of in the proper place. And then I will come over here to the first red LED and bring it in, long leg, And that darn one is not wanting to go in. Sometimes if your wires are crooked a little bit, it doesn't want to go in. You got to really kind of try to bring them straight down when you do this. This one is quite stubborn. Okay, there it goes. Make sure that, you see I've got things packed in, but make sure that the resistors are not touching each other. Okay, make sure the resistors aren't touching each other. Okay, here is the next one. Okay. Number 7 went right in, and now we go to number 8. Okay. Now this is where it's very easy to make a mistake, to kind of be off by 1 pin. And so what we want to do is we want to come in and verify that each one of those resistors actually is in the same column as its LED. And then what we also want to do is we want to make sure that none of those resistors are touching each other, because we've packed them in there pretty tightly. And I think that that looks pretty good. Okay, what we want to do now is we want to hook up the other end of these resistors to the control pins on the 74HC595. And so the first wire is going to need to be a little longer, and I'm going to come to this first current limiting resistor, and then it is going to go over to, let's look and show it really big here. Okay, that first resistor needs to go over to that Q0. Okay, do you remember the Q0? That is pin 15. Okay, so I got to be kind of careful with this. I got to make sure that I'm coming all the way over. I'm coming all the way over to pin 15. And so that would be right there. Okay, do you see that? Remember, we count the pins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so let's see if we can get that thing to focus there. The focusing with this camera is sometimes the biggest challenge. Okay, that's not too bad. Hopefully you can see it. It'll get a clearer focus here in a minute. Okay, so that's the first one. Then where does the second one go? The second one is going to go, I think I can show it clearer here. The second LED with its resistor is going to go to, it looks like pin 1. And so let's verify that here. Yes, Q0 was 15. That's output 0 is 15. Output 1 is going to be pin 1. Okay, output 1 is pin 1. And I will speed up here in a minute, but I just don't want you to get lost as I'm getting started. Okay, so this next one is going to go to pin 1. Okay, you see that? Pin 1. All right. The next one, this is going to go kind of fast now. Just make sure that you get in the same column. Make sure that you don't miss that column. Is going to come to pin 2. Okay. You see that? The third one goes to pin 2. And then we are going to go to pin 3. Next one to pin 4. Next one to pin 5. Next one to pin 6, and I'm just going to count to make sure. 1, 2, okay, do you see this? 1, 2, 3, 4, 5, 6. Okay, so things are looking good there. And then the last one will go to pin 7. All right, and then I want to get this wire out of the way. I had to use a little bit of a longer wire there. All right, so do you see now we have our ground rail established. We have the complete circuit for the 8 LEDs hooked up. And so what do we need to do now? What we need to do now, I'm still bugged by wanting these things in here aligned perfectly. And it is just not ever going to be as perfect as I would like it on those LEDs. Okay, so we have our LED circuit hooked up, and we've got our ground rail established. I like to kind of do this in a logical order. And so what would be a good thing to do now? I think maybe the good thing to do now would be to bring in our 5 volts to create a 5-volt rail. And we do in fact need a 5-volt rail, so I will do that now. I will get a red wire to just remind us that it's 5 volts. I will come from the 5 volts on the Arduino, and then I will come over here and create a 5-volt rail in that second row. Okay, that second row is now a 5-volt rail. Now, where does that 5 volts need to go? Well, one place it needs to go is it needs to go to the VCC on the chip. And where is that VCC? That VCC is pin 16. Okay, where is pin 16 for us? Pin 16 would be all the way up here in the upper left. Okay, that would be pin 16, and that one is going to need to go to our rail, our positive rail. Okay, and let's see what else is going on here. I need to do a little tiny bit of bookkeeping here. I'm sorry, I just need to make sure that I am not doing anything on this Arduino while we're trying to hook it up, so I'm basically loading up bare minimum. So give me just a second here, guys. Don't hate me because of this. Okay. I think I've got things loaded up. All right, so let's go back. We've got our power there. Let's see, there's a couple of other things that need to be connected to that power, and let's go ahead and take care of that. So you see they're creating the power rail on the bottom row, and that looks like it is also going to pin, let's see, 8, 9, 10. Okay, it's going to pin 10. And so let's make sure that we come in and do that. And what is pin 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That pin 10 is the master reset. And so it's active when it's low. So if you don't want to clear, you want it high. Okay, so if you make it low, it re-clears everything. If you don't want it re-cleared, you better put it high. So master reset is going to go high. And that is just something that we need to do. So that would be master reset would be high. So here we come to master reset pin 10, and it is going to go high. All right. So we brought pin 10, we brought high. Let's look and see what else we need to do. Is there anything else that needs to be high? So I'm looking at their bottom row, and I see that the only thing that they're bringing off of that is that pin 10. All right. What else needs to be grounded? Well, it looks like if I have 16, 15, 14, it looks like 13 needs to be low. And so let's see what pin 13 is. pin 13 is output enable. So if you want the output enabled, it's active when it's low. Well, we want an output, so we better put 13 low. Okay, so this is 8, 9, 10, 11, 12, 13. Okay, this is bugging me that this thing is coming on and off, and I wish it wouldn't. Okay, you see we kind of have it in an intermediate state, and that's why it's blinking on us like that. Okay, so this is pin 13, 14, 15, 16. This is pin 13, and then we said that we wanted that to be low, so I will put that in the top row, which is our ground rail, right? Our ground rail is that top row, and so we now have that pin 13 set low. Okay. Well, I wish it would focus that good every time. Maybe I found the sweet spot there. All right, so let's go back and let's look at this. And so we have all the bottom row hooked up. We have not grounded the entire thing, which we need to do. That if we look here, let's see, what is that? Pin 8. Okay, pin 8 is the major ground, and so we need to do that. And for us, pin 8 is this end one on the bottom. Okay, the end one on the bottom needs to be grounded, and that will come up to our top row to ground it. If you guys don't like doing this with me, just skip forward on the video to the coding part and look at it. But the reason I do it with you, man, hooking it up is the hardest thing. And so I kind of talk you through it to let you see how I think while I'm doing it. And you kind of see that I'm trying to be methodical. Now I have most of it done, but we've got to come back here and we have to see that we need a shift register clock, we need a latch pin, and we need the data input. And so the data input, which is pin 14, is going to go to Arduino 12. Okay, pin 14 on the chip is going to go to Arduino 12. So pin 14 on the chip, so this is 8, 9, 10, 11, 12, 13, 14, is going to go to pin 12 on the Arduino. Okay, digital pin 12 on the Arduino. And let's look and make sure that that's right according to this, if these things agree. And we can see that pin 12 does in fact go up to 14. All right, now let's see what the other thing that we need to do is we need pin 12 to go to Arduino 11. Pin 12 to go to Arduino 11. So here we have 8, 9, 10, 11, 12. So that's 12 on the chip goes to Arduino pin 11. Okay, 12 on the chip goes to Arduino pin 11. And then let's check and make sure that that's in agreement with our main circuit diagram. So we have pin 9, 10, 11, 12 goes to pin 11. Okay, pin 12 goes to pin 11 on the Arduino. All right, we have one more thing to hook up, and what that is, the one more thing that we have to hook up is, I believe, pin 9, which is going to be the clock pin. So pin 11 on the chip goes to pin 9 on the Arduino. Okay, 11 goes to 9. So this is 8, 9, 10, 11 on the chip. 11 on the chip is going to go to 9 on the Arduino. 9 on the Arduino. And it was amazing how well that thing focused earlier. Okay. So you can see we got kind of a mess here, but I feel pretty good. I actually feel pretty good because I feel like that we went through it methodically and carefully. We got 5 volts. We do have a ground that is making everything a ground. And I think at this point we are in pretty good shape as far as hoping that this thing is going to work. So let me try to get those out of the way. Seems like it really wants to focus back on that. It's like it sees the brand, it sees the lettering, and it really wants to focus on that. So let me see if I can, maybe I can prop this up and try to help it keep the focus a little better. Give it something to look at. Okay. All right, sorry I'm not doing a better job on the focus. Okay, well I think we have this thing pretty much built now. So now we need to go in and we need to start programming it. So let's see if I can find a good code view for you. I will come back over here. That's our overhead view. I could move this up a little bit more like that so you've got a good view of it from the overhead. Okay. So there I think you can pretty much see everything. Okay, so that is kind of all set up now. So now we need to start coding. So let's look and see if I can find a good coding view for you. Okay, that is not what I want. Okay, that's pretty good. That's pretty good. All right, so we need to start coding this thing. And it's pretty straightforward. Okay, it is pretty straightforward. We've got, how many pins were we using? We were using 3 pins. Okay, and so I'm going to have int latch pin is equal to, remember, where did the latch pin go to on our circuit here? The latch pin went to 11 on the Arduino. So back here in code view, we will set latch pin to 11. Okay, and as you saw there also, int clock pin was connected to 9, and then the data pin, which we said was so important, I believe that was 14, was connected to 12. So that has set up those critical pins that we send the data. Those are the ones where we send the data. Okay, now we need to, and man, I hope you guys watch lesson number 41, because there we learned about hexadecimal numbers. And if you haven't watched that one, you got to go back and do it, because what we do is we're going to set up a hexadecimal number. A hexadecimal number is 8 bits, 4 and 4. A hex number, as far as the Arduino is, it is 8 bits, which then are 2 characters. And so we have to set that up. Well, let's set it up to begin with by setting it. How do we declare a hex number? We call it a byte. And we're going to call it our LEDs. And let's just set it to, how do I tell it it's fixing to be a hex number? 0x. That's just saying, hey Arduino, listen up. The number that's coming your way is a hex. So 0x says hex incoming. And then what number do I want? Well, if I want to turn all the LEDs on, what would that be? 1, 1, 1, 1, and then 1, 1, 1, 1. It would be 8 ones. But to input it as a hex, what is 1, 1, 1, 1? That is F. What is 1, 1, 1, 1? That is F. Please go back and watch the last video if you haven't seen it. But this is saying that the number that I'm going to send to this serial to parallel converter is FF, which is 1111 1111. What should that do? That should turn all the LEDs on. Now we come down here and we better do our pin modes. So I'm going to have pin mode. Latch pin is an output. Okay. Pin mode, did I do that right? Yeah. Data pin is an output. And then pin mode clock pin is an output, because all those things we are writing to. Now you're probably kind of afraid of this clock business. You're probably kind of afraid of the clock business, but don't worry, there's a simple command that will take care of all this clocking nonsense. So now, what did I say we wanted to do with latch pin? When we are ready to send data to the converter, the serial to parallel converter, we've got to take the latch pin low. That's saying data incoming. So how would I do that? Digital write LATCH pin low. All right. Now that it's low, we want Arduino to send out through that pin, pin 12. On pin 12, we want to send out the data. So how do we do that? We do a new command called shift out. And what do? We got to say, what pin do we want to send the data out through on the Arduino? Well, we want to send it out the data pin. And that data pin was pin 12. And that goes to pin 14, I believe, on the chip. So that is the data pin. We also have to tell Arduino which pin to use as the clock pin, because that's going to be doing the synchronization. So we just say clock pin. So you see, that was all you had to worry about with the clock. That clocking goes on between the Arduino and the 74HC595. You don't have to worry about it other than telling it where it is connected. Now we have to do something that is just saying, right, it's like, are you sending the bits in this way, where they're going into the least significant bit first or the most significant bit first? It's kind of like, which order are you sending them in? It is least significant bit first. Okay. I could spend 30 minutes trying to explain this to you, but I will say the right answer for how we wired the circuit is the least significant bit first. If you wired it up differently, or you're working on a project and don't understand it, doesn't work, do instead of the least significant bit first, do the most significant bit first. That's the other possibility. And then you've got to tell it, okay, you've got to tell it what is the data packet that you're sending. Well, for us, it's LEDs, and that's the FF. So to send it the FF, we say LEDs. Okay, so that we send. Now what do we need to do? Well, we need to take that latch pin high, because we've sent the data. Digital, right? And then I have latch pin like that, high. Okay, so now I want you to think about this. When we download this, what do you expect? Okay, I set LEDs to FF. What is FF? 1111 1111. Well, if I'm sending all ones to the LEDs, what do I expect the LEDs to do? All come on. Why do I turn them all on to begin with? Well, because it lets me see if I have my circuit hooked up right. If I have something hooked up wrong, the LED isn't going to come on. I do need you to take a big drink of coffee. This is huge. A lot of coding, a lot of circuit. The tension. You could cut the tension with a knife at this point. What is the chance that this is going to work? What is the chance that I didn't goof something up, particularly over here in this latch pin, clock pin, data pin, or forgot a ground somewhere? There's a lot that could go wrong. So I need everyone to hold their breath. Oh, it downloaded, but the LEDs did not come on. So we have a problem here. LEDs is 0FF. We took the latch pin as an output. We took the data pin as an output. We took the clock pin as an output. We made latch pin low. We sent data pin, clock pin, LEDs, and then we did a digital write. We did a shift out. Man, and we are not getting anything. And so I wonder, a little wire had come out. My VCC had come out, okay? But now we are getting partial success, but I don't have everything coming in. So I need to just come in and make sure that all my wires are in nice and snug. Okay, everything in nice and snug. Okay, like what am I doing? I'm making sure that all those resistors that I put in are in fact all the way in, and I am having what looks like a difficulty with a couple of these. That is in. So you see at this point we're not sure, is it a circuit problem on the LED circuit side, or is it a, and let me just go over here. I think probably what we're going to do is we're going to give you a better view as I try to debug this thing, because the chances are probably more likely it is something not hooked up right. So I'm going to come in and put this current limiting resistor back in and make sure that I get it in. Okay. Okay, it's kind of hard to do it when it's in the middle, but that should be in. What would be another possibility? What if I plugged it in upside down, the LED, and short leg goes to ground? That does look good. Okay. Short leg to ground. That looks good. You know what? You know what? All right. Sorry for all of that delay, but I hope you see, you look at your circuit, you look at the code, you look at the circuit, you look at the code. The chip itself had sort of popped out, and so now all of a sudden it is looking a lot more promising. Okay, it is looking a lot more promising. The last thing that I wrote was FF. So let's come back down here to let's see, let me go to this code view, okay, and then let me add, let's say, duplicate shot, and then I will come down here and I will take this out. Man, I'm going to get a lot of hate on this. I know I am. All right, so let's go to add another shot. And let's add the 920, add. Okay, so now you can see the code and you can see both cameras like that. Okay, so now let's go in and let's start doing some coding. And I want to get this where it will stand up better so you can see it. I think maybe something like this. Okay, and now I will come and look right at it. Okay, so FF puts them all on. We are rolling now. Man, that was painful, wasn't it? I wonder if it was as painful for you as it was for me. Now, what if I put 0, 0? What do you expect? What do you expect if I put 0, 0? You expect them all to be off. And boom, they are all off. What if I put 1, 1? Well, hexadecimal 1 is 0, 0, 0, 1, and hexadecimal 1 is 0, 0, 0, 1, so we would expect off, 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 on, off, 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 on. So let's look at that and see what happens. Boom. Okay. What if I wanted it to go, let's say, on, off, 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 on, off, off, off? I think that, if I am not mistaken, would be an 8 and an 8. Let's see. Boom. Okay. On, off, off, on, off, off. I am just now really wanting to get a more dramatic, zoomed in focus view. So let's see if I can get this to focus. Okay, now that is looking pretty good. Pretty darn good. Okay. So now, let's look at another way, right? On a byte, we can put it in hexadecimal. You remember what we could also do? Instead of 0x for hexadecimal, we could also say 0 binary, and then you just type them in 0, 1, 0, 1, 0, 1, 0, 1, and you can just type in the pattern that you want, just like that, okay? Ooh. Oh, this should be a 0 up there. 0B stands for binary, and then you just put the pattern that you want in there, okay? Hopefully. Hopefully. Ah, boom, look at that. Okay, did you see that? Now let's go 1, 0, 1, 0, 1, 0, 1, 0. And then that should switch the other way. Okay? All right. Now that gives me the idea. What if we came down here and we sort of copied those, control copy, and then what if we control pasted, and then what if we said delay of delay time, and then what if we said delay of delay time, okay? And then what if we came back up here and made an int of delay time of 5, let's make it 250, make it a little more snazzy. And then we had an LED 1, which is that, and then what if we had a byte LED 2, which LED 2S, which was equal to the binary 0, 1, 0, 1, 0, 1, 0, 1. Okay, and now we would, down here, we would just need to write LED 1s, LED, where was that? LED 1s and LED 2s. Now what do you expect this to do? Go back and forth, right? Wow, look at that. Okay, pretty darn neat. Okay, you starting to see how this thing works? Man, I apologize that this was such a painful lesson, but you know, for me, it's like I could go back, and when I have a problem, I could redo the video, right? When I have a problem, I could redo the video, and then I could go through it and make it work perfectly. But I want you to see that you're never going to do it perfectly. And one of the hardest things to learn when you're an engineer or when you're doing this type of project is it doesn't work. You've got to figure out why. It could be a bad component. It could be a bad wire. It could be a circuit hooked up wrong. It could be bad coding. Okay, so did you see? I'd look at the code, I'd look at the circuit. I verified that the LEDs were in fact working. They weren't burned out. I verified my LED circuits, and then it was sort of working, sort of not working. And you could see then I was thinking, bad wire, bad connection, somewhere a bad wire, somewhere a bad connection. And then what I found was that the chip itself had kind of popped out, and it was just sitting there, but it wasn't all the way in, and so it had intermittent connections, and that was the problem. You will have homework. Oh yes, there will be homework. All right. So with 8 LEDs, what could I count to in binary? I could count to 255. That would be 1111, 1111. Using the shift register, I want you to make a binary counter that will count to 255 using the shift register connected to the Arduino. Now, I'm going to give you a warning. This sounds real easy, but then what it's going to become is it's probably going to become very hard. And you're going to think it's easy, and then you're going to start doing it, and then it's going to just be really, really, really hard. So I will give you a heads up. I will tell you that there actually is a very, very, very easy way to do this. And just using the circuit that you have now, there's a very easy way to make a binary counter. So make it work come what may, but be looking for the kind of simpler, elegant solution to do the thing. It does not take hundreds of lines of code. It takes just a few more lines of code, very few more lines of code than what we have right now. Okay, this is Paul McWhorter from TopTechBoy.com. I hope you guys enjoyed this lesson. I hope you understand why when things go wrong, I don't stop and just do the hard part while you're not watching. I'm the guy that's trying to help you learn, and so I need you, of the things that you're learning, I need you to learn how to debug and troubleshoot when there's a problem. So I'm sorry the video was long, but I think there was a real purpose to it. Give me a thumbs up if you like this. Think about subscribing to the channel. If you do, make sure you ring the bell. If you hit that bell, you will get a notification when I have new things posted. And really would love to hear your comments down below. Were you guys able to get this up and working? Did you have other problems were you able to troubleshoot your problem? So let me know. Really appreciate it when I see that people are actually watching these videos. So I will talk to you guys later.